In this video, we'll be learning how to solve quadratic word problems that have a function that is written in intercept form. So here it says the function below models your first golf shot, where x is the horizontal distance in yards and g of x is the corresponding height in yards. So when we look at this function, what I'm noticing is that this function is written in intercept form. So some key information that I can kind of rewrite and then identify here is this would really be g of x is equal to negative 0.02, that x by itself can have an x plus 0, and that can be x minus 80. So here what I can identify, because this is written in intercept form, is I can identify my x-intercept. So this first x-intercept is 0, 0, and the second x-intercept is the opposite of negative 80, so that's 80, 0. So what I can really draw over here is I can draw a little sketch of what is going on. So here I have an x-intercept at 0, 0, so I can see that. I then have an x-intercept here at 80, 0. And then I know that my golf shot is going up and down to connect the two. So I can see my parabola there. So here it says find the maximum height of the ball during our shot. So here we're trying to find out the maximum height at this particular point. So we need to find our vertex. And looking here, the easiest way to find our vertex is to find our axis of symmetry and then plug that into the equation. And here I notice that because I have intercept form, I know that my axis of symmetry is halfway in between, which in this case happens to be 40. So here my x value of my coordinate with my vertex has a distance away from us, or a distance traveled horizontally, of 40 yards. And it has x is equal to 40 yards. So what we can do is we can take this x value, substitute it into our equation, and we can find the corresponding height value right here. So this one is 40, and we're trying to find the corresponding height value. So here we'll take our function and we'll say, well, the y value is going to be equal to negative 0.02 times 40 times, that's going to be 40 minus 80. Well, that becomes negative 0.02 times 40 times a negative 40. And if I use my calculator to calculate this, I find that the height of my golf ball in this moment is 32 yards. So here what this tells me is that when I've traveled 40 yards horizontally, I'm reaching my maximum height of 32 yards up high. Then part B of this question says, how far does your shot travel before it hits the ground? Well, we know that it goes up 32 yards horizontally, and at that point it's reached a distance away from us of 40. And because this is symmetric, it actually takes 40 more yards further to fall down. So you can see here's our entire distance traveled, and it's 80 yards horizontally in total that this travels away from us when we hit that golf ball. So now let's take a look at word problem number 2. So this one says Anna dives into a pool off of a springboard high dive. Her height in meters above the water, x seconds after diving, is modeled by the following. So here we can see that we're written in intercept form, and we've got intercepts at negative 1, 0, and 3, 0. So let's draw a little sketch of this situation. So here we have a y-intercept at negative 1, 0. And then we have another y-intercept at 3, 0. So this is kind of the way that this looks. Now, it might not make sense to you that right here at time 0, so that's the time is 0 right here, that Anna's right here, but if you think about it, she's starting on a high dive. So at time 0, she is above the water by some distance, and when she dives off, she is going to go up for just a little bit and then come back down. So question A says, what height above the water is Anna at the time that she dives? So at the time that she dives, her time is 0 seconds. And so what we're going to do is we're going to know that x is equal to 0 here, and we're going to plug this value into our equation in order to determine what height Anna was at when she started to dive. So here we have negative 5 times, well, 0 plus 1 is 1, and 0 plus negative 3 is negative 3. So I just took 0 and substituted it into both of these, and then as a result, well, negative 5 times 1 is negative 5, negative 5 times negative 3 is 15. So Anna starts 15 feet above the water. So this diving board is 15 feet above the water. Then from here it says, what is Anna's maximum height? So if we look here, Anna's maximum height occurs at the vertex point. And remember, when we're in intercept form, we can find our axis of symmetry and vertex by taking the average of our two x-intercepts. So here, our axis of symmetry occurs at x equals 1. So if we take x equals 1 and we put it into this original equation, we can find Anna's maximum height at the time of 1 second, which is where we reach that peak and reach that highest point in our dive. So here we take the equation and we say negative 5 times, well, 1 plus 1 is 2, and 1 minus 3 is negative 2. So negative 5 times 2 is negative 10. Negative 10 times 2 is 20 feet. So Anna's maximum height is 20 feet above the water. So what this tells us is we started at 15 feet above the water, and then we rose up 5 feet before falling back down. Now this last part here says how many total seconds is Anna in the air? And for this, we can actually refer right back to our graph. If we look carefully, here at time 0 is where we start, and our x-intercept here at 3 seconds is when we are hitting the water. So here we can see that we are in the air for a total of 3 seconds because we start diving at time 0 and we're entering the water at time 3, which represents 3 seconds in the air in total.